Hello students. So again, I'm here with the chapter of breathing and exchange of gases. And today we are going to do respiratory volume and capacities as we are progressing in the chapter. So the difficulty level is also increasing and the interest level should also increase. So we will again start on a very positive note. You are dreaming to become a doctor, and to fulfill that dream we are taking baby steps. So if you can dream it, you can do it. Always believe in yourself that if you can dream it, you can do it. Okay, so now let's start with the chapter respiratory volumes and capacities, right? So what should we do first? Air in the lungs is measured in terms of lung volumes and lung capacities. So what are lung volumes and lung capacities? It is a way to measure the air in the lungs. Okay, so lung volumes and lung capacities are a way to measure air in the lungs. When we are talking about lung volume, we are taking just one function. Okay, and when we are talking about lung capacities, we are talking about two or more volumes. Remember this. Okay, volume, when we are talking about, it measures the amount of air for one function, whereas capacity, it is any two or more volumes. Okay, so now just a little common sense, that we don't run as fast as cheetah, do we? No, cheetah runs very fast. So it needs, what does it needs more? It needs more, it needs a much higher lung capacity. Why? So as to provide oxygen. Where? To all the muscles in the body. Why? To allow it to run very fast. Okay, elephants, very big animals, they also need a high lung capacity. Why? Because their body is very large and their need to take up oxygen is in accordance with their body size. Now, human lung size, that is determined by genetics, gender, and height. Okay, this is an important thing. An average lung can hold at almost 6 liters of air. Okay, but the lungs usually do not operate at maximal capacity. We'll very shortly learn it why. Okay, we'll learn it why. So now let us start with respiratory volumes. What? Respiratory volumes. So the first respiratory volume that we are going to study is tidal volume. What it is? It is tidal volume. Okay, it is what? It is the air inspired or expired. Air inspired or air expired. What? The volume of air inspired or air expired. Okay, so as I had said, that volume is one function. It is volume of air inspired or volume of air expired, or a different way of saying, volume of one breath. Okay, volume of one breath. That is what? That is tidal volume. And how much is this? This is approximately 500 milliliters of air. Okay, so if we assume that the respiratory rate of a normal adult during a quiet breathing or a normal breathing is 12 to 16 times per minute. So how much air it is the person inspired or expiring in 1 minute? So air inspired in 1 minute to like 500 into 16. So around 6,000 to 8,000 milliliter of air in 1 minute. Okay, so this is what? 6,000 to 8,000. This is minute ventilation. Minute ventilation. Why? Because we are using the respiratory rate that is like 12 or 16 per minute. So what we can say that the minute ventilation is what? It is tidal volume into respiratory rate. It is minute ventilation is tidal volume into respiratory rate. No confusion till here. Okay, tidal volume is the volume of air inspired or air expired. Okay, so it is the volume of one breath. Now, this is the tidal volume. How much was the tidal volume? 500 ml. Awesome. You know everything, right? 500. So, in this 500, what is the 70%? What is the 70% of 500? 350 ml. And 30% is 150 milliliters of air. I had already told you in my previous lectures about the respiratory and the conducting parts, right? Where does the conducting part ends? Tell me. It ends at the terminal bronchioles. And where does the respiratory part begins? It begins at the respiratory bronchioles, then to alveolar ducts, alveolar sacs, and finally to alveoli. Okay, so this 350 ml that participates in the respiratory, that actually reaches the respiratory part. That actually reaches the respiratory part. And this 150 ml, this remains in the conducting part. Remains in the conducting part. Okay, so what is the respiratory part and what is the conducting part? You know, conducting part ends at terminal bronchioles. Okay, if you don't know this, please see the previous videos. And where does the respiratory part begins? It begins at where? It begins at respiratory bronchioles. Okay, right. So we have done tidal volume. We have done this how much is participating, 70 and 30%. Okay, so now we will do some more things, and this 30%, that is this 30% that is not taking that is not taking part, that is not taking part in respiratory exchange, that is not taking part in respiratory exchange, this 30%, that is 150 ml of air, it is known as the respiratory dead space, respiratory dead space, or anatomic dead space. So if the question comes, what is the quantity of, now the question can be framed in many ways. Respiratory dead space, first they can ask this, or what is the quantity of anatomic dead space, or what is the quantity of tidal volume not participating in gas exchange, right? So what will be the answer? What is the quantity of these things? It is 150 milliliters of air. Okay, this is anatomic or respiratory dead space that is not participating in the gaseous exchange. Okay, so we had learned minute ventilation. Remember, minute ventilation was what? Minute ventilation was respiratory rate into tidal volume. Suppose we are assuming it as 12 into 500, so it was 6,000 milliliters of air. Now we know that only 30% of this 500 is participating in gaseous exchange. So what will be the alveolar ventilation rate? What will be the alveolar ventilation rate? And that will be, if we say that that the person is breathing 12 times per minute, so it will be 4200 milliliter per minute. Okay, it is what? It is the volume of air. It is the volume of air per minute, volume of air per minute that actually reaches the respiratory zone, because the other 30% is actually not reaching the respiratory zone. It is in the conducting pathways. Okay, now let us see the other one. Now let us see the inspiratory reserve volume, right? Inspiratory reserve volume, and volume is always one function. So, and capacities are two or more functions. Inspiratory reserve volume, it is what? Inspiratory reserve volume. Okay, so it is what? It is normal inspiration. It is normal inspiration plus forced inspiration. Okay, it is the additional amount of air. It is the additional amount of air that can be taken in by forced what? Forced inspiration after normal inspiration. So we normally inspire 500 milliliters of air plus more. So this additional amount is how much? This additional amount is 2500 to 3000 ml. Okay, this additional amount. So this is what? This is like inspiratory reserve volume will be how much? 500 plus 2500 to 3000 milliliters of air. Okay, similarly, now if we see expiratory reserve volume. Expiratory reserve volume. What is expiratory reserve volume? If we see, the short form is ERV. It is the extra amount of air that can be inspired if inspiration follows forced expiration. Okay, so it means if you inspire normally and then expire as forcefully as you can do. You do a normal inspiration and then you just expire forcefully. You should be able to push out considerably more air in addition to 500 ml of tidal volume, because tidal volume was what? 500 ml. That is volume of one breath. Remember, volume of one breath. That means one inspiration or expiration. Okay, so what is this? This is normal inspiration and then forced exhalation. Okay, and then forced as much as you can. So this is around what? This additional air is around 1000 ml or 200 ml. Notice the difference in that was forced inhalation was how much? 2500 to 3000. Now we'll do residual volume. Residual volume. Even after we expire forcefully, some air remains in the lungs. Some air remains in the lungs even after forceful exhalation. Now, that's not possible that we exhale forcefully and then, our alveoli become, it's not like they'll just burst or they'll just pop out that, we have all the airs that was our inside. We have exhaled all the air. No, that is not possible. Why is it not possible? Because of the non-collapsible airways that we have. It is not possible that we exhale all the air that we have. Okay, so this air that remains after forceful exhalation, this volume of air is known as residual volume, and it is around how much? This is around 100 ml to 1200 ml. Okay, and one important thing about residual volume, it cannot be measured by spirometry. Spirometry is an apparatus, a spirometer is an apparatus by which we can measure IRV or ERV, tidal volume. Okay, but residual air volume cannot be measured. So now we have done with respiratory volumes. Now we will come to respiratory. Now we will come to respiratory capacities. Okay, respiratory capacities. So the first respiratory capacity that we are going to do is, okay, now let me show you a diagram and then you will understand more, I think. So now let us not study like that. We will study this by a graph. Let's try that. Let's try doing like that. Okay. So if we draw a graph, okay, so here is the lung volume along with time. So this is air in milliliters. So what we had learned that tidal volume was 500 ml. Okay, normal inspiration and normal expiration. So if we see, this is normal inspiration going on, normal inspiration and normal expiration going on. Now what happens? This is tidal volume. Now you take a very big breath, or you forcefully inspire around how much? 2500 to 3000. Now you inspire how much? 2500 to 3000. That is what? That was inspiratory reserve volume. Remember, IRV. So that becomes what? This becomes inspiratory reserve volume. Okay. Inspiratory reserve volume. Now you want to expire also. And how much you can expire? You can expire something around 1000. So you expire also. Now you expire also. Forceful expiration. Okay, so this becomes expiratory reserve volume. And what is left because of the non-collapsible airways we have? The residual volume. You know this much. You don't know anything about respiratory capacities. Okay, right? So inspiratory reserve volume, tidal volume, and expiratory reserve volume. This is the volume of air a person can breathe in after a forceful expiration, or the volume of air a person can breathe out after a forced inspiration. So this is what? This is the vital capacity. So this whole, this is what? This is vital capacity, right? So vital capacity is what? It is vital capacity. It is the sum of what? Inspiratory reserve volume, tidal volume, and expiratory reserve volume. Understood? Please see it properly. Okay. Now this is the vital capacity and this is the residual volume. Okay. And the total of vital capacity plus residual volume. This is what? This is total lung capacity. This whole is what? This is, if I just extend it, so this is what? This is total lung capacity. Okay. And if we see, this is the tidal volume. Okay. And this is the inspiratory reserve volume. Okay. So what is the total of sum of tidal volume and inspiratory reserve volume? It is the expiratory capacity. What is this? This is the expiratory capacity. Similarly, this is the tidal volume. This is the inspiratory reserve volume. And this is what? This is the inspiratory capacity. Okay. Tidal volume, normal, one breath. Inspiratory reserve volume, forceful inspiration. Okay. And expiratory reserve volume, you breathe normally and you exhale out a lot forcefully. Okay. So the sum of tidal volume and expiratory reserve volume, expiratory capacity. Very good. So we have done inspiratory capacity, expiratory capacity, and vital capacity, and total lung capacity. Okay. Now there is one more capacity that is given or sometime asked. It is the sum of residual volume and expiratory reserve volume. What is this? What is this known as? It is functional residual capacity. And what is this? This is the volume of air that will remain in the lungs after normal expiration. Okay. So let's once again just see if we have just revise and see if we have got everything. We have done tidal volume. It is 500 ml of air. 500 ml of air. Okay. It is normal breathe. Okay. One inspiration or expiration. Okay. Whenever I'm saying this, revising, everything should go in your mind. Minute ventilation is what? Respiratory rate into tidal volume. Okay, like 12 or 16 into 500. So it came to around 6,000 to 8,000 milliliters of air. Anatomic or respiratory dead space. What was that? That was the 150 ml of air that was not participating in what? In gas exchange. In gas exchange. And where was it lying? Where what is remaining? It remained in the conducting airways. Okay, it remained in the conducting airways. How much percentage of tidal volume? 30% of tidal. And now this one word more, physiologic dead space. I guess I did not take it. It is what? It is like the this respiratory dead space. Respiratory dead space plus the non-functional alveoli. Non-functional alveoli volume. Okay. So alveolar ventilation rate we had done. What was alveolar ventilation rate? 70% of tidal volume. That was how much? 350 ml of air. We had assumed that the person is breathing 12 times per minute, and so 4,200 milliliter per minute. Okay. Now then we had done inspiratory reserve volume. This amount of air, the additional amount of air, additional amount of air by what? By forceful breathing, right? Remember, by forceful inspiring. And what was this additional amount? This was around 2500 to 3000 milliliters of air. Okay. Now, similarly, expiratory is a volume. We breathe normally, we take in air normally, and then we forcefully expire. That is expiratory reserve volume. It was around 1000 or 200 ml of air. And what was residual volume? The air that the considerable amount of air that remains in the lungs. The air that remains in the lungs. Okay. And whenever I'm writing this next point should automatically come to your mind. Right. 1100 to 1200 milliliter of air. This is residual volume. When I'm writing one thing, you should be so crystal clear in your concepts that the next point should automatically come to you. Okay. Now the respiratory capacities we had done with the help of the graph. So the first thing is inspiratory or inspiratory capacity, or we can also write it IC. What was this? This is the sum of what? Remember, tidal volume and inspiratory reserve volume. So inspiratory capacity is tidal volume plus inspiratory reserve volume. Similarly, expiratory capacity was what? It was sum of tidal volume plus expiratory reserve volume. Very nice. Functional residual capacity, it was what? Residual volume plus expiratory reserve volume. Okay, it is what? It is the volume of air. It is the volume of air that will remain in the lungs after normal expiration. Functional residual capacity. Functional residual capacity. What was vital capacity? Vital capacity was what? It was sum of inspiratory reserve volume plus tidal volume plus expiratory reserve volume. I'm writing in this order so that you can remember the graph. Okay, inspiratory reserve volume plus tidal volume plus expiratory reserve volume. And what was total lung capacity? The total lung capacity was the vital capacity plus residual volume. And what is vital capacity? It is inspiratory reserve volume plus tidal volume plus expiratory reserve volume plus residual volume is total lung capacity. Okay, it is the total lung capacity, and it is around how much? It is around 5000 to 6000 milliliter of air. Okay, so in the next class, I will be taking a lot of questions. I'll be taking a lot of questions, and we will be starting with exchange of gases. Okay, so the next class will be what? Next class will be questions and exchange of gases. So you revise this all that we have done. Okay, so we can just see what we have done today. We started with the respiratory volumes and capacities. Volume is what? Volume is one function. Capacity is what? Capacity is one or more volumes. Then we saw about cheetahs and elephants, and then we saw about different respiratory volumes. We saw about tidal volume. We saw about tidal volume, respiratory rate, minute ventilation. Okay, then we saw about this 70% and 30%, and then we did a question, and then we did alveolar ventilation rate, then we did inspiratory reserve volume. Okay, expiratory reserve volume, then we did residual volume, then we did this graph, okay, which is an important graph. If you want, I can revise once again. This is the tidal volume. Okay, normal inspiration, normal expiration, inspiration, expiration. And this is the inspiratory reserve volume. That is after quiet breathing, much more forceful inspiration that you can take in. And expiratory reserve volume, right? Then we did this residual volume, the air that is remaining in the lungs, that is remaining in the passageways, air passageways. Then we did this various capacities, inspiratory capacity and expiratory capacity. We did inspiratory capacity, expiratory capacity, functional residual capacity, vital capacity, total lung capacity. Please remember this graph. Okay, please remember this graph. It's important. Okay, it's important. It is important to remember this. If you remember this graph, you can answer all the questions of volume, respiratory volumes, and respiratory capacity. Okay, then we just revised everything. And one thing more, you should know about all these volumes. How much is their quantity? Okay, you should know all these volumes. Okay, that's very important. You should know all these volumes. So that's why you remember that graph, and you should remember these quantities also. Then we did respiratory capacities. Okay, then we did inspiratory capacity, tidal volume plus inspiratory reserve volume, expiratory capacity, tidal volume plus expiratory reserve volume. Okay, and functional residual capacity, vital capacity, total lung capacity. So respiratory volumes and capacities is done. And as I told you, next I will be taking questions and exchange of gases, which is a very important thing to know. And then after this exchange of gases, I will be taking, this will be the next lecture. And after that, next will be transport of gases. Next will be transport of gases. So guys, please study hard and don't take any stress. Just be happy. You have a dream. We are just fulfilling that dream, nothing more. Okay, so have fun, stay home, be healthy. Bye bye.